All right. If it's continuous at 0, then by definition of continuity, the limit as x approaches 0 from the left, which uses which branch, which function? Shout it out, come on. The top one, pi sine of x over x. Now, if you don't know why I'm saying that, then let me know. We'll go over it. Do you understand why that function? That needs to equal the limit as x approaches 0 from the right. 0 from the right is above 0, which is a minus bx. See? Okay. Now, that should also equal the point, which I'm not going to worry about because wouldn't you agree that actually at 0 is the same as a minus bx? So whatever the limit is for a minus bx is going to be the same as the actual point itself. So I would normally say equals f at 0 here, but these are the same, so I don't need to sweat that. So I'm just going to do this. This guy. So now we're getting into those limit skills we just worked on. It's a numerical one, so let's try direct substitution. When you direct sub, what do you get? You get 0 over 0. Okay, now we would normally say, all right, can we do some algebra to work with that problem? And if not, should we use a table or pick up a calculator? Now, first of all, that pi, this is a limit rule, but that pi really is a non-issue. I could actually bring it out front and say I need to focus on what the x's approach. We just talked about what is sine of x over x approach. What does it approach? 1. And so if this approaches 1, and then I multiply it by pi, this limit is actually pi. Now, I definitely didn't think you would have that. I assumed that you would pick up the calculator and graph that and look at what happens as you get closer to 0. So that's how you could have had pi on your own. You with me? On the right-hand side, I need to look at this function and say as x goes to 0, and then that kooks me out because I have 3 different variables there, a, b, and x. The only one I know about what it's doing is x. If x goes to 0, what happens to this? It just is a. Well, boom, you just found a. A has to be pi. So far, so good? Questions? All right, now moving on, we need to get these guys meeting seamlessly. So if we look at 1, then we need the limit as x approaches 1 from below to equal the limit as x approaches 1 from above for continuity. From below, what function do I use? A minus bx. But I might as well put in my a value, which is pi. So pi minus bx needs to match the other guy, which from above is our tangent, right? Let's do the limits. As x goes to 1, what is pi minus bx approach? If x goes to 1, then x becomes 1 by direct substitution, so I get pi minus b, or b times 1. The right side, arctangent of approaching 1. What is the arctangent of 1 by direct substitution? At what angle is tangent equal to 1? Pi over 4. All right, and then it's just a little bit of mental problem solving. Pi minus what would be pi over 4? You could do the algebra, but I just think 1 whole minus 1 equals 1 fourth. 3 fourths, 3 pi over 4, right? There is, I gave you the answers yesterday, but more importantly, that's what it came. Any questions there? Okay. How about 18? Is that still a question? All right. Sometimes people have an epiphany, so I just check it. 18. And then perhaps 19 because it follows it. All right, so here we go. When you say slope between 2 points, it's change in y over change in x, or y2 minus y1 over x2 minus x1. So in this case, y2 minus y1. That's f of x plus h minus f of x. Those are the y's. Change in x. That's x plus h for the second minus x for the first. So far, so good? All right, now, you might think, well, why not then? They said given the same function, so I'm supposed to actually get a little more specific. So in other words, actually use the function here that they give you. F of x plus h. F of x plus h means put x plus h in a function. Wouldn't you agree that f is something squared plus 1? And what am I putting in? X plus h. I'm putting in x plus h. Then I come, that's this part. Then I come to this part. F of x again is something squared plus 1, and f of x is putting what in? Just x. In other words, there's f of x right there. I could have just put it. What does the denominator clean up to be? H, yeah? The x is subtract what? Okay. Let's continue on then. Actually, I guess I would be okay if you stopped there, but I think you're going to want it cleaned up a little for 19, so let's clean it up, all right? What is x plus h squared? Square binomial. When you square that out, what do you get? X squared plus 2xh plus h squared. Excellent skills. Plus 1. And that backside, make sure you distribute the negative. We'd get a negative x squared minus 1, right? All said and done then, the x squared subtract away, and the 1s subtract away, leaving you with 2xh plus h squared all over h. How does that simplify? 2x plus 1. H divides away, right? All right. Now, using your answer from 18, find the slope between the 2 points as the distance between them goes to 0. Now, you're probably thinking, what the heck? I should have done a numerical case. Now, this one I might have done a little bit of an overreach here. Sorry, my bad. What is the distance between the 2 points? Read carefully in 18. And a point H away. Yes?
I was just going to say, it should be 2x plus h.
Oh, perfect. Thank you. Because that is, thank you. You're absolutely right. Well done. All right. That actually is going to be great. Much better. So on this one, the distance between, we want to take the distance between them going to 0. Well, the distance between them is h. It says a point H away. I started at x. I went h a little off to the side. So the distance between them is h. So if I want to take the distance between them to 0, then I want to take h to 0 of that rule. Now, limit skills. As h goes to 0, what does that approach? Just 2x. The h drops away and it becomes 2x. Now, whether you know it or not, people, you just found the derivative of x squared plus 1. The derivative of x squared plus 1 is 2x. Now, what the heck that means, that's for tomorrow. But trying to get you the algebra skills here. Right? 18 and 19, check. Any other questions on continuity? Okay, let's go to last night's homework, intermediate value theorem. I did post my key to my website, but I didn't tell you ahead of time I would, so I wouldn't be surprised if you haven't looked at it yet. So let's talk about answers to this bad boy, but do know that my key is online if we don't get through all the questions, all right? The only question is, where is my actual There it is. Okay. Did we talk about, no, we did not. Number 1. So intermediate value theorem, first of all, is H is continuous, yes? It's said already, so you don't need to say it again. Now we talk about the betweenness. What is H at 0? -5. What is H at the other endpoint, 5? 11. H moves continuously from -5 to 11. Does it have to pass through 3.3 along the way as it goes from -5 to 11?
Yes.
It does. And so the wording would be something like this. H is continuous, and 3.3 is between -5 and 11, or you could also call them H at 0 and H at 5 if you like. So by the intermediate value theorem, there must be, they called it, now use their wording, they're talking about saying, must there be some R, which is an X value. There must be an R in the region 0 to 5 such that H at that value has to equal. Okay? Something along those lines. Questions? Yes? Why is this one? Is that what you're asking? You see it? Okay, gotcha. Oh, you looked at the wrong column in the table. Okay, no worries. All right, 2 we did together, yes? Okay, 3. 3 is, instead of numerical, it's graphical. Same idea, though. F and G are both continuous. What happens if you put 2 continuous functions together? You get a continuous function. Okay, so K is continuous, and that's because F and G are. All right, there's no breaks in the graphs there. They're continuous, smooth curves, so they're at least in the window, basically. Right? Let's talk about endpoints. How about K at? I want to investigate K at the first endpoint, so K at -2. K at -2 is F of G of -2. Let's work inside out. I'm going to color code these. This is G. I tend to get confused between the 2 graphs sometimes, and so this is. All right. So I first need G at -2. What is G at -2? These axes aren't very clear. G at -2 is, did you get -2 there? Do you agree?
Yes.
Okay. G at -2 is -2. Now I put -2 into F. F at -2, here's the F curve. F at -2 is +2. Cool. What did you get for K at 3, anybody? Shout it out. 2. 2? Oh, that's not good. I'm going to hope I disagree with you. All right, let's start with G of 3. I'm on the blue curve. G at 3 is 2, right? Okay, G of 3 is 2. Now I put 2 into F. F at 2 is the green curve at 2. What's the green curve at 2? 3. Okay? Now then, as K goes from 2 to 3 continuously, must have passed through 2.74. Yeah. All right, so here's our conclusion. K is continuous, and the betweenness is satisfied. The point you asked about, 2.74, is between 2 and 3, the endpoints. So by IVT, or intermediate value theorem, there is they call it P this time, there is a P in the region -2 to 3, where K at that P equals 2.74. Cool. We didn't do this in class, did we?
No.
All right, this one's a hard one. This one's from a CU calculus one final a couple of years ago. They didn't give them any help. It was just that. Prove there must be a solution to it. No calculus. That's a hard question. That goes to whether you really have IDT at the forefront of your mind here. So this one's difficult. It, first of all, doesn't tell you use IDT. Second, it doesn't give you endpoints. All that's difficult. So first of all, IVT, why must that pass through? Let's call this, let's kind of rephrase it so it looks more like a question I'm used to. I'm going to call that the function, and I'm trying to show why it has to pass through 0 in some interval. Now, I'm going to make an interval. That's actually quite freeing. It's my choice. My hope is that I could, if I want to show it 0, then I probably want to find some endpoints where f is what? What's on either side of 0? Negative and positive. So I want to try and find some points where this curve would come out to be negative and positive. Let's take some guesses. At 0, 0 is a great value to work with. Do you agree? I gave you that. So what about f at 0? What is it? 0 cubed plus sine of 0 minus 1.2 is negative 1.2. Now that's nice. I'm hoping to then find another point where the curve goes positive, right? Now, you might think, well, gosh, I have no idea what that graph looks like. That's okay. Remember, for thousands of years, before about 1995, people didn't have a graphing calculator, and they still were able to work it out. And so you can too. It goes a little something like this. Think about x cubed. X cubed gets really large, right? Whereas sine stays pretty small. And so if we just choose an x a little down the road, won't the cube eventually win and we'll start to get positive? Right? Right? So the question is, just try something. Give me a number that I could put in here that would be fairly easy to look at without a calculator. One's a nice number, but do you know the sign of 1? No, me either. How about the sign of something clean? 2 pi or pi? How about that? Let's just go pi for the sake of argument, all right? F at pi would be pi cubed plus sine of pi minus 1.2. Now I have some good news for you. I don't actually need to figure out what to see. All I need to show is that it is positive. That's all. Okay? Now pi cubed, what is it? Ballpark. What's pi like? 3. What's 3 cubed? Oh, try again. Okay, 27. All right. So 27. This is about 27, probably a little more. What's sine of pi? What? 0. About 27 minus 1.2. Definitely positive. Right? All right then. I forgot the continuity part. F cubes are continuous. Sine is continuous. Is the combination continuous? Yes. It is. F is continuous. If you really wanted to overachieve, you could say parenthetically x cubed and sine are both continuous, but you don't need to. Therefore, we're ready to set our conclusion. F is actually, let's just start with what I have. F is continuous, and that 0. F equals 0 is between these 2 points. Now you could either call them negative 1.2, but you could say F equals 0, or I'm starting to get myself a little wordy here. That 0 is between F at 0 and F at pi, because it's between negative and positive. So by IVT, there must be now you could call it an X, or just say a place where, in what region must this happen? There must be a place in 0 to pi where what happens? X equals 0 or F equals 0? A function equals 0. Okay? That was a hard one. All right. This comes next in the sheet, is that right? Yeah. So I went 1, 2, 3, 4, 16. Okie dokie. 18. Did we do 18 together? Okay. What about 19? Did we do that? All right. Did you find? I'm just going to do some just have it. Let me have my key. I can do number 19. Can you do number 19? Okay, well, there you go. All right. Yes, I'll be happy to do number 19. So you've got this, think of it like this. You've got two graphs, 3x plus 2, and k minus e to the x, which looks like this. And in order for them to meet specifically at 1, you're going to have to play with it just a little so they meet perfectly. All right? That's the idea. And then, of course, they're not both over the whole domain. Use the definition of continuity. The definition of continuity says the limit from the left equals the limit from the right. So, the limit from the left. The left of what? 1. Okay? And if I go from the left, what function do I use? The top one. Left is less than 1. Less than 1 means use this one. And that needs to equal the limit from the right, which is what function? 3x plus 2. This should technically equal f at 1, but f at 1 and approaching 1 are the same, so I'm not going to even go there. It's the same as 3x plus 2, so no sweat. All right. Are you looking so far? Okay, now what do? Find the limits. What does this limit or this function approach? As x goes to 1, this approaches. Which one do I put in 1? Do I put in 1 for k or x? X. So this approaches k, just stays k, I guess. K minus e to the 1. And what about on the other side? 5. Okay, now this then is going to go to teacher preference. And this makes me crazy. I have then to get k by itself, and so k is 5 plus e. Now, my preference slash just good math. It's tempting then for students to say, okay, well, that's no good. I need to pick up my calculator. So they pick up a calculator and give me a decimal approximation, right? Why? Why? Did it take more work to put that into your calculator as opposed to just leave it alone? More work, right? Which is better? This answer, which is perfect and exact, over your calculated answer, which is an approximation. Now my question is, why would you pick up your calculator for more work and a less exact answer? Please explain that to me. Why would you do that? Your answer is that. Leave it alone. Do not use your calculator. You're going to give me an approximation and a word approximation. I want it exactly, and that's exact. You follow? Yes. Okay. Oh, look at the Easter egg. All right. How about this boy? I really wish I could find my. Oh, here it is. Nope, that's not it. All right. So in the back, number 20. Did you get a bunch of 5s in continuity? Or no, that's not what you got. We should go. Okay, bunch of 5s. If you got a bunch of 5s with limits, then you're good. Would you agree at like the same token? The limit from the left of 1 just occurred to me. I say, would you agree a lot? Sorry, I'll try and eliminate that. That makes me crazy when people have a tip like that. The right, 5 cosine of x minus 1. Would you concur? Okay. And that equals the point itself. What's the left-hand limit, or the first limit? 3x squared plus 2 at 1 is 5. Okay? What about the right-hand limit? As x goes to 1, I get cosine of 0. Cosine of 0 is 1. 1 times 5 is 5. Now, that's actually not the complete definition of continuity. Right now, I could have that. I also need in there that's equal to the point itself. And otherwise, words check that 1 is defined. Wouldn't you agree that 1 is defined, and that must also be 5? Okay? So, because of that, F, we can conclude that F, or G, G is continuous at x equal 1. pause for a second, just to nip that in the bud. I almost screwed up and wrote F there. On the AP test, if the problem involves G, but you call it F, just because that's habit, you will lose points. For silly reasons. So read carefully, use what they call it, right? 21. 21 is 1, is what I got. How about you?
Yes.
Okay, we'll go back over that in a second. Let's get you the answers here, just in case. This is 1. Not, you don't agree with 1? I think so? Yeah, I think it's 1. All right, this one is negative infinity. Here I get, I didn't finish this. Where did I get there? Negative 2? Negative 3 halves? Negative 3 halves. Okay, this I have is 2. Me?
Yes.
2? How does that doesn't even, oh yeah, that makes sense. Yeah, 2. Right on, man. 2, do we all agree? Can I get a uh-huh? Do I have any uh-uh? Okay, if x approaches 0, then do I use at 0 or approaching 0? Approaching 0. And if I use this rule at 0, I get e to the 0 plus 1, which is 2. Remember, limits are approach at its core. All right, so it is 2. F. All asymptotes of this guy. So first, I'm going to rewrite it cleaner. I can take out an x and an x. And what is going on at x equals 0? Is it asymptotic or is it whole? Whole. And what's the fancy vocabulary for whole? Removable discontinuity. All right. How do I approach vertical asymptotes? Vertical asymptotes. Vertical asymptotes happen at, when what? 0 in the denominator, only the denominator. So where is there a vertical asymptote? At x equal negative 1/2. Horizontal asymptotes, where do they happen, or how do I investigate that? End behavior, infinite limit. As x gets infinitely large, this approaches the limit as x goes to infinity of this guy approaches. I heard just somebody just say it over here. Do you agree dominant terms here are negative 1/2? Yeah?
Yes.
Negative 1/2 is a great limit, but it's not an asymptote. Give me the equation of the asymptote that that implies. Y equals negative 1/2. It is not complete without saying the equation of the asymptote is y equal negative 1/2. Next. These are very common algebra errors. Trying to help us out before we get to calculus. Calculus, a lot of calculus errors are not because the calculus is hard. Calculus is easy. The algebra sometimes is hard. So this is fine. This is garbage. Let's go with this idea. A times B equals 0. What do you know? One of them must be 0 or both, right? You know that. Must be. A times B equals 12. What do you know? Nothing. You know nothing.
United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I'm going to work on that blood skills. I should be able to hear myself. You should be so loud.
Lunchtime reminder. Enjoy your full lunch period. Don't line up 10 minutes before the bell. This is for passing period. Please make sure to pick up after yourself. Help your friends when they forget to clean up. Or stay in the designated seating area and not wander through the hall very much. Today, the set hours to the school report to the 6,000. Ole Hack, brought to you by the DHS Cross Country Team. Load up on side. You can double your rice and beans and add the heat of any and entree at no cost. Try this tip when you come see the Cross Country Team at Chipotle on 285 in Wadsworth on Monday, August 27th, 4 days ago.
perform an artwork on September 4th at 7:30 a.m. to the office. The winner will receive $50 in addition to having their artwork on the cover of this year's directory.
Boys who want to participate in Boys Mentoring need to get their enrollment form from counseling right away and turn it in by Monday. Even if you were in Boys Mentoring last year, you'll need to turn in another form.
If you are interested in working on the stage crew for Our Town, there will be a brief 10 to 15-minute meeting this Friday after school at 2:35 in Mr. Murphy's room.
Pictures needed tomorrow for all students who did not have pictures taken on registration day. The forms in the main office. Don't forget to comb your hair.
Thanks.
Have you bugged your parents enough to get them to sign you up for the Death of Dash this Saturday? If not, you need to. Time is running out.
Yeah, love your parents.
You may only check out Chromebooks during the 10-minute passing period before 7th hour. Please return Chromebooks immediately after 7th hour. If you have an overdue item, you will not be able to check out a Chromebook. Always remember, Chromebooks are for academic use only.
Senior high students, seniors, please return your senior yearbook submission forms to Mr. Jacobson's room by September 7th. Extras will be in Mr. Jacobson's room. Also, don't forget that senior photos and baby pictures are due September 7th as well. Instructions are on the school website. Email the yearbook.jack@gmail.com with any questions.
Listen up, junior high students. The middle school tennis league is starting September 10th. Practices will be on Mondays and Wednesdays, 5 to 6:30. The Devil Court will match on Saturday. All ability levels, including beginners. Look for a flyer in the office.
All right. There's more work on my key poster online, so if you're confused, I'd be happy to help you.
Please try to keep your pictures taken.
I'll be walking around.